weather and climate often cause concern and curiosity, but understanding the facts behind the phenomena can be a challenge. We're here to help. From the University of Illinois, Urbana-Champaign, and Illinois Public Media, welcome to Weather Realness, a weekly podcast about the skies above Illinois and the world.
Welcome back to Weather Realness. I'm Steve Nesbitt, head of the Department of Climate, Meteorology, and Atmospheric Sciences at the University of Illinois Urbana-Champaign. From Doppler radar to satellites to aircraft, scientists use different types of tools to observe the weather. But one of the most important tools meteorologists use to this day are weather balloons. The National Weather Service launches weather balloons twice a day nationwide.
Yeah, in fact, they're used twice a day here, not only in Lincoln, but all around the country. You know, we get so much weather data at the surface, but there's a lot of atmosphere that's above us, and these weather balloons are a great way to sample what's going on in the sky, whether it's a few thousand feet up or even tens of thousands of feet up in the air.
For context, most commercial jets fly around 30 to 40,000 feet. Talking to us today about the science behind weather balloons is Eddie Wolf, a PhD student at the University of Illinois Department of Climate, Meteorology, and Atmospheric Sciences. Thank you for joining us, Eddie.
Thank you for having me.
So first of all, can you just simply describe what is a weather balloon and what kind of data it collects?
Yeah, so I think everybody's familiar with like a home weather station, these things you put in your backyard. It has the little wind vane on it, the little anemometer, and tells you what the temperature is out in your backyard. And basically the idea of the weather balloon is to take that sensor and let it rise up through the entire height of the atmosphere. So it's really important to know what's happening down at the surface, but a lot of our weather is being caused by what's happening really high aloft, these large-scale weather patterns, these wind fields, the temperature, the humidity at these really high altitudes. So basically what we do is we take an instrument like that, looks a little bit different, and we attach it to one of these large helium balloons, and we just let it rise up through the entire height of the atmosphere and tell us what these atmospheric variables are at all of these different levels.
So just like we see on the news, we're seeing temperature, pressure, humidity, and winds, just like we would on a surface weather station, but we're rising up through the atmosphere.
Yep.
So are there any complications in doing that?
Yeah, so I mean, I think the first one that comes to mind is you can't just attach something like a wind vane to one of these balloons and measure what the wind speed and direction are at these heights. So what they do instead is attach a GPS unit, and you're able to back out what the wind speed is based on the motion of the balloon at all these different altitudes. So that's sort of a way we've been able to engineer around sort of the problems that we have with that.
Yeah, so basically the wind blows the balloon wherever it's going to go, and we just make the assumption that the wind is the speed that is moving.
Yep.
So, I mean, obviously weather stations on the ground, they're made out of typically plastic or metal, but we obviously don't want to launch that off every 12 hours. So what are some of the materials that are in these balloons?
Yeah, so the actual sensor is still, again, mostly plastic and some metal components as well. But we also attach a parachute to it. So obviously once the balloon gets up to that really high altitude, the balloon will burst. And the parachute helps it fall safely back down to the earth. There's also what's called a derailleur attached to that. So as the balloon's rising, it's letting out string and allowing the actual radio sonde, the weather sensor, to fall farther and farther away from the balloon so that as the balloon's flying around the atmosphere, the sensor doesn't accidentally hit the balloon or something like that. So then all those components eventually slowly and safely fall back down to the earth once the balloon bursts.
So how do we get the data off of the balloons?
Yeah, so in addition to all of the weather sensors, there's also a radio transmitter. And just like you would, tune into your local NPR station, it's sending via radio waves these packets of information back to our ground station we have and letting us collect the data remotely that way.
So does this ever go wrong?
Very often. I can think of a few examples from my now 5 years here where we've had some interesting experiences with launching balloons, especially when you get near very interesting and especially very windy weather.
Yeah, we'll talk a little bit about that later, but obviously the sensor has to work, but then also you have to deal with the logistics of actually launching something into the atmosphere, which can be a little tricky, especially if you have a lot of trees or buildings or power lines or other things. So we'll touch on that later. So talking about the history of this, we've been doing this for a long time. Mm-hmm. Can you describe a little bit about maybe the history of ballooning?
Yeah, I mean, the Weather Service has been doing this for a long time. I think this is one of the earliest. I mean, it's a very simple way of getting information about high up in the atmosphere. Nowadays, we also have things like satellites and airplanes to do that. But I mean, dating back to the really early days of the Weather Service, they were using balloons. This was the easiest way to get something really high into the atmosphere. I mean, this is how we traveled through the air back then. Before we had airplanes, we used hot air balloons, and it was basically a similar system for getting weather data.
And typically we would put some gas into these balloons.
Mm-hmm.
Can you talk a little bit about that?
Yeah, so what we use here in the department is helium. Helium's obviously a little bit expensive, but it's also very safe. It's not flammable. What most of the Weather Service offices in the United States use now is actually hydrogen. They're able to use hydrogen generators because they're at these usually pretty remote sites near airports. They're able to have these generators that create hydrogen for them on demand, and they can fill the balloons with that. Obviously, with it being flammable, that's not something we want to be carrying around. We do a lot of launches remotely as part of field campaigns. We're driving around with these tanks, and we don't want hydrogen doing anything volatile while we're doing that.
Yeah, we don't want students reproducing the Hindenburg, obviously.
Exactly.
But, I mean, there are ways you can mitigate that with like grounding devices to make sure that the person that's doing it is not going to torch off their eyebrows.
Yeah, I know the Weather Service has protocols for that as well, and they do hydrogen launches. They have like ways to tie themselves down to the ground as they're doing it so they don't create any sparks.
So can you talk a little bit about why we launch these so often in the atmosphere?
Yeah, I mean, the atmosphere is constantly changing. So what we do nationwide and worldwide is these 2 launches every day at 0 UTC and 12 UTC, which I think comes out to something like 7 a.m. and 7 p.m. here, depending on the time change. But even with that, there's so many things that change over that 12-hour period. So what we do a lot in the department is with these coordinated field campaigns, we try to launch even more frequent balloons very close to interesting weather. So something like hourly launches really near thunderstorms. So we can see how the environment's changing over these small time scales and how that might be influencing the weather that ends up happening.
So you mentioned there's other technologies that we can use like satellites. Mm-hmm. What still makes weather balloons the best way to observe the weather patterns?
Yeah, I mean, I know with satellites especially, one of the big challenges still is clouds. When you have cloud cover over an area, that really limits how well those satellites are able to determine the profile of the atmosphere there. So even with all the advancements we have with these new technologies, there's still utility in just launching a balloon, especially in these short time scales with field projects every hour near storms where you might not have satellite overpasses during that time, or there might be cloud cover because of the storms that you can't get that information any other way.
So you've worked a lot with radio sounds in the field. Can you actually walk us through the process of launching a balloon?
Yeah, so the first step is to basically get out your radio sonde, so this little instrument, and connect it to a computer so we can initialize it, tell it what the ground conditions are so it can sort of calibrate itself. After that, we build what we call the balloon train. So we attach to the radio sonde the derailleur, which, like I said, sort of allows the radio sonde to fall away from the balloon over time as it's rising. And then we attach a parachute so it falls safely back to the Earth. Once we have all that put together, we'll fill up the actual balloon. So we bring a big tank of helium with us. We fill the balloon usually with something like 200 psi of helium. Usually gets about 4 feet across or so. Once it's up at the top of the atmosphere, that ends up being the size of like a small car because it expands as it rises. But even with it being 4 feet across, it's a little bit unwieldy. So we have somebody holding that, somebody with a balloon train. We attach those together. Then we make sure that the sonde is both getting good measurements down at the ground and also connecting to GPS satellites. That's oftentimes an issue when you're in like a dense urban area. So you have to make sure you're in a space that's large enough that you can actually have visual to all those different satellites to get GPS signal. Then once that's ready to go, normally somebody stays at the computer and sort of gives the thumbs up to the folks that are launching the balloon, and then they let it go and we start collecting data.
Yeah, so this has evolved over the years. Even during my career, I launched some soundings that were prior to the GPS era where we had to use something called LORAN, which was a satellite navigation, ground-based, I think, combination of navigation aids to be able to track the balloon. But even prior to that, there were weather balloons that were actually tracked with what's called a theodolite, which is like a surveyor equipment where you actually had to measure the elevation and azimuth of the balloon as it ascended. You had to kind of assume an ascent rate. But using that, you could actually get a profile as well. Obviously, if you lost visual on it, you were out of luck. Yeah. But that kind of goes back to the early histories. And prior to that, there were these things called pilot balloons where they just tried to track the winds using the motion of the balloon. So it's been around for a long time, and there are various levels of technology here. So if you're just tuning in, you're listening to Weather Realness, the weekly podcast about weather and climate. Today we're talking about the use of weather balloons with Eddie Wolf, graduate research assistant in the Department of Climate, Meteorology, and Atmospheric Sciences at the University of Illinois Urbana-Champaign. Yeah, so you've studied tornadoes and severe storms. How do weather balloons help you understand what's happening inside those storms?
Yeah, so I think like I mentioned before, the atmosphere changes constantly, and especially really near these storms, it's evolving really rapidly. So being able to get balloons that are really close to where these storms are happening, we can see sort of how the storm is modifying its environment, how the environment is changing in the near term, and sort of allowing that storm to evolve differently. One of the big things we look at is CAPE, so the amount of instability in the atmosphere, which is a function of sort of the temperature and the humidity as you go up with height. So that's something you really need a balloon in order to calculate. And also things like wind shear, so how the winds are changing with height. That's really important for storm development and changes on really small scales, especially when you're in something like a storm's inflow. So being able to get balloon launches really close to storms really helps us better understand what the environment they're actually experiencing is and how that's changing with the weather that ends up happening.
Yeah, and you mentioned sort of this 15 to 20 minute time scale, and we've actually got newer technology called a wind sonde where we can actually launch multiple of these at the same time to even try to map things on a finer spatial scale, and they actually look like a little styrofoam cup. They're much cheaper sensors, but we can launch more of them to be able to get that high spatial and temporal sampling that we want. So can you walk us through a time where you were kind of pressured to get this off? You mentioned last Friday night here in Champaign-Urbana where we had some storms nearby.
Yeah, so that was one where, we saw the line of storms coming in. Steve had reached out and asked if we could get a balloon off, and we happened to be in the area, so we drove over to the building and very quickly put it all together. That was one where, as we were getting the balloon prepped and about to let go, the tornado sirens start going off. We were in a tornado warning. Thankfully, our building is very, very nice building, has a good basement. So once we launched it, we were able to head back inside really quickly and take shelter. But yeah, definitely, as you're launching, you see lightning off in the distance. Winds are picking up. Winds picking up is not a great thing when you're trying to launch a balloon because, with obstructions like trees and stuff, that quickly becomes a complicated situation. But yeah, we were able to get one off then.
Yeah, sometimes when the wind's really strong, the ascent is quite slow.
Yes.
And we've had quite a few, I would call them white knuckle events, where we're trying to clear power lines in the distance, and you're kind of hoping that these things can get up above those targets. But, launching in an urban area obviously can be really tricky and UIUC campus is full of obstructions. It gets a little tricky.
Yeah, for ones like the one on Friday, Liam and I kind of gave each other a look and we're like, are we going to overfill this one a little bit? And we're like, yeah, we're going to overfill this one because if you put a lot more helium in it, you get more of that vertical ascent and less of that horizontal ascent, which becomes very important once you start getting some high winds.
So have you ever had to launch a weather balloon in another dangerous weather situation?
Oh, that's a good question. The other ones that come to mind, I think, are all also severe weather events at our building. There was one a little over a year ago, very similar situation. We were in a tornado warning. Storms were coming. We had a lot of undergrads there as well who were doing this as part of class. And that was one that unfortunately did not make it off the campus. It met its fate with a tree down the street from our building. But
So what happens in that case? Do we try to recover them?
So in that particular case, we decided, we're responsible for these undergraduate students as well. There was a lot of lightning sort of coming to the area, so we called it then. We sent everybody inside to just take shelter. But a lot of times on field projects, if you lose a balloon, the protocol is to switch to a different frequency. We sort of have these different frequencies allotted to us on these projects where we can transmit without overlapping with other people's data. And you sort of switch to your secondary and you try to launch a second balloon if you can in that same time frame to make sure you still get the data.
And the National Weather Service does put a address and info if somebody does find one of these out in the wild on their land, they can send it back and we can oftentimes recover the sensor and reuse it.
Yeah. And there's a lovely website called SondHub where regular folks can track balloons as well and sort of see all these launches happen every day and where they end up.
So when you're launching, you mentioned sort of ground targets. I mean, obviously there's aircraft as well. Do pilots try to avoid these things, or how do we mitigate that potential conflict?
Yeah, so a lot of times what we do is we file what's called a NOTAM, which is a Notice to Airmen, or I think the name's different now, but basically letting folks in the area know, especially with the Champaign Airport being nearby, that there might be things rising through the atmosphere at a certain time, and just sort of be aware of that. At the end of the day, there's hundreds of these launched around the world every day, and very few incidents have ever happened with airplanes. The reality is it's just these are very small packages in a very large atmosphere. So the odds of somebody coming into contact with them are pretty low at the end of the day, but it's always good to be better safe rather than sorry.
Yeah, and the launches that we do, the sensors weigh less than 400 grams, which is the limit for FAA even being concerned about collision, so it shouldn't really cause any damage. So if you're just tuning in, you're listening to Weather Realness, the weekly podcast about weather and climate. Today we're talking about the use of weather balloons with Eddie Wolf, graduate research assistant in the Department of Climate, Meteorology, and Atmospheric Sciences at the University of Illinois Urbana-Champaign. During field campaigns, we can launch quite a few of these, and we've done experiments where we've actually launched over 1,000 of these over a period, and sometimes the public does find these on their property. We usually put a sticker on them that says harmless weather instrument. Can you say why we do that?
Yeah, I think, we're oftentimes going into people's neighborhoods, into their states, and doing these experiments, and we don't want to sort of be a hassle to them or cause any harm to them. So doing this is sort of a way of letting them know, this is for science. We're trying to better understand the atmosphere in your area. There's not a reason to be concerned about this. I mean, something strange falls on your property with a big parachute tied to it. Like, you don't know if that's radioactive or something crazy. So it's a good way for us to let folks know that, what we're doing is trying to help people and not cause any undue harm to them.
Yeah, and I think there's sensitivity, especially after a few years ago where there was sort of this unidentified balloon that was cruising over the United States.
New at 4, the Pentagon says this Chinese balloon being used for surveillance is flying some 60,000 feet above the central U.S. It's now heading east.
As the situation unfolds, the U.S. Secretary of State, Antony Blinken, he's postponed a high-stakes diplomatic trip to China that was set for this weekend.
Some concern that this was a weather balloon or something more nefarious, and I think everybody has become a little more sensitive about these things.
Oh, yeah. And we were doing a project right around that time, and there was definitely concern with, especially we were launching in a very urban area up in Chicago of, we need to make sure we let people know ahead of time we're going to be doing this in your area, and this is just harmless weather sort of things happening.
Yeah, so definitely launching balloons in the field campaign definitely gets a lot of attention, and, I've noticed that you're typically going out and deploying in maybe a remote area. People start to get curious about what you're doing. Have you ever had anybody come up to the vehicle and sort of ask questions?
Oh, yeah, all the time. After doing this for a couple of years, you definitely start to get like a little spiel that you do when people start asking questions because you get asked so often. Some people recognize it's a weather balloon. They go like, oh, are you like meteorologists? This is for weather. Other people come up and they have no idea. They'll be like, what are you doing? Like, just... what's that thing? What's this? A lot of times they point to the antenna. So we have this large antenna on a tripod that we use to receive the data back from the balloon. That catches people's attention a lot. Large tripod with mysterious object on the top of it. That's like, oh, are you tracking something? So you get a lot of questions. Usually people are very, very friendly. They're very interested, just curious what's happening. I've never had issues with anybody, being upset that we're there. They're just genuinely curious what we're up to.
Yeah, we did a project in Argentina back in 2018-19 called Relámpago, which was studying severe storms in a hail hotspot there in central Argentina. And we definitely gathered a lot of attention. People, some people were very curious. Some people were very happy that our crews were there and they would bring food.
Oh, yeah.
You're stationed there for 12 hours. People would notice that you're sitting there doing work. We got fed empanadas and ice cream and other things. But also, I mean, you get people's curiosity, but you also get sometimes people's sort of other axes that they might want to grind about the weather, about the forecast being inaccurate, or even conspiracies. And we did have one run-in with somebody who, I was driving down the road with a group of students and we had pulled off. And a car pulls up behind me, and I'm like, "Oh, cool! We've got somebody asking questions." And they were speaking Spanish. Unfortunately, I know enough Spanish to be dangerous. And the man started asking, like, "Did you cause hail to fall on my farm the other day? I noticed that there was an aircraft flying over. Are you doing this research project we heard about in the news?" And there was quite a bit of public outreach with that campaign, and people knew about it. But yeah, people oftentimes, even before the current sort of increase in conspiracy theories, they look at scientists a little bit skeptically. So we have to kind of put on our nice face and respond respectfully and say, well, we're about to measure the temperature and humidity above here. We are not intending to cause any other effects here. We're trying to improve forecasts so that you might be able to avoid hail damage in the future. So right now, launching balloons is a very manual process. It takes time. Typically these things cost about $200 to $300 to launch each one. Can you talk a little bit about future technology that might help us do this maybe more cheaply or more automated in the future?
Yeah, so I know something a lot of weather service offices, especially in rural places like up in Alaska, have started doing is they have these automated systems where within this little enclosure, a balloon is filled, the radio sonde's already attached to it, and sort of remotely they're able to hit a button and the enclosure opens up and the balloon flies out on its own essentially. And all they have to do is go and restock, something like the helium or the hydrogen and the supplies every now and then, but they don't actually have to be there doing the launch at every, 12 hours, which is really helpful in these really rural and mountainous areas out there. So, something that a few different places have started looking at is using these drones essentially and attaching the same exact sensor to the back of a drone. And then instead of, having to release a balloon and let it fly away, you can actually control the drone ascending and descending. And you can do that a lot more frequently then since you're not actually losing, any instrumentation when you're doing that. You don't have any expendables, as we would say.
So we're talking about the use of weather balloons with Eddie Wolf, a graduate research assistant at the Department of Climate, Meteorology, and Atmospheric Sciences at the University of Illinois Champaign. Thank you, Eddie, for talking with us.
Thanks for having me.
What weather or climate topic would you like us to talk about next? Leave us a message at 217-333-2141. Again, 217-333-2141. Weather Realness is produced by Stephanie Oriana, Jeff Frame, Reginald Hardwick, and me, Steve Nesbitt. It's produced by the University of Illinois Urbana-Champaign and Illinois Public Media. Thanks for joining us. Stay safe. We'll talk with you again next week.